I've just checked the logbook, which I use to keep track of the time that I spend on building this project, and it's been about just a little bit over a month since I showed you the completion of the front half of the fuselage. Now, as you can see, that's been all taken apart, disassembled and labeled and put aside. The carry-through spar for the wing has been turned around 180 degrees and set back up on the table, and the aft or rear section, the tail section sides, have been put into place and secured to the table in their proper locations. And then all of the cross members and diagonals and support pieces that need to go in have all been fabricated, cut and fitted, and put into place. And they're all held in place by bits of wire and strapping and clamps and rubber bands and electrical tape and whatever else is useful to hold everything together to keep it in alignment. The tail post fin has been simulated with a piece of scrap 1-inch tubing. One of the most difficult parts of this assembly was to cut the longerons at the ends to fit this tail post assembly where the tail section is going to go. And that has to be done very precisely. This has to be kept at a 61-degree angle from the table, and various tools were used to measure that to make sure everything is fitted correctly. Now, the next step in this is sort of a monumentous occasion. We're about 5 months into the project right now, and both the fore and aft sections of the fuselage have been completed. All the pieces are cut and fitted and ready to go. The next step would be to take all this apart, take this table apart, move out into the garage, set everything back up again, and start welding the pieces together. So the next time you see us, we'll be out in the garage starting to work out there. So it's about time to get going. That last scene was shot in the basement, and that was around the end of June. It's now the second week in August, and I'd like to bring you up to date on what's been accomplished since then. The beginning of July, the table and everything was moved out into the garage, where we are now, and the table was set up and leveled, just like it was before, and the carry-through spar and the fuselage sides were all put back into place, all realigned, with all the cross members and diagonals put into place. And then got interrupted by a little thing called EAA convention in Oshkosh at the end of July and beginning of August. At that point, after a very enjoyable convention, I came back and was raring to go. So we started tack welding everything together. The sides have been tack welded and then finish welded to the carry-through spar. All the rest of the components have been tack welded into place, and then the upper front cross member has been finished welded. This cluster and the other cluster on top have been finished welded, and this cluster right here was finished welded and realigned because it was a little bit out of alignment. The next step in this is to take this off the bench, since everything's all pretty rigid now after it's been tack welded, and build up a fuselage rotator jig, which is recommended by the EAA welding manual, so that we can put this out to the middle of the floor and be able to rotate it around for the final finish welding. So that's the next step, and we're going to get started on that right now. It only took a few hours to construct this stand, and it looks like it's going to be worth it. It'll help be able to position the fuselage in any position to make it easier to weld. And I'll take all the help I can get. So the next step is to start welding, and we're going to start with this cluster joint right here. And we'll be able to weld the whole cluster joint by rotating the fuselage to make it easier to get at. It's time to get started on that now.
process used for final welding all of the cluster joints is that described in the EAA aircraft welding manual. Starting at the firewall and working from front to rear, each cluster is welded using the same procedure. First, the entire cluster is heated evenly before starting to weld. Then each tubing joint is welded by melting their base materials while adding filler rod as necessary, in a continuous motion as much as possible around the cluster. When the entire cluster's welding is finished, then the torch is backed off slowly after heating the entire cluster again. This process relieves stress on the joint caused by the welding process. I chose to start with the top left corner of Station 1, which is where the firewall will attach, and work my way clockwise around the station from one cluster to the next. After Station 1 is finished, I moved on to Station 2, and so on. If you want to build a steel tube airframe, you will need to learn how to be ambidextrous while welding. Some welds may be easier to do with the torch in your left hand, and some will be better from the right. It pays to practice using either hand to hold torch or filler rod. Some parts of a cluster weld easier than others. For instance, the inside angles of a weld require more heat than where the outside areas have tubing that overlaps flatly. If possible, start with the outer part of the cluster and work into the angle intersections. The metal will be preheated already, making it easier to weld.
Yesterday I managed to finish welding the left side lower cluster, and today I'm ready to tackle the right side cluster, and hopefully we can get more than one cluster done today.